All right, everyone, we'll go right into checking our homework this morning. We had page 52, questions 1 to 6 for homework, all, I believe, on acceleration. If you remember, we have now 6 equations. We went from 1 equation one day to 6 equations the next day. The first equation that I usually write in red, that we call our group A equation, V equals d over t. Our group B equations that I usually circle in blue, A is equal to delta V over delta t. D is equal to VIT plus 1/2 AP squared. So run out of space here. D is equal to VFT minus 1/2 AT squared. Going to run out of space. Doesn't matter. I don't need to write them all out here. VF squared is equal to VI squared plus 2AD. D is equal to VI plus VF over 2 times T. Okay, all of these group B equations are valid when you have acceleration. The group A equation circled in red here is valid when you have a constant velocity. I believe all of these questions that I assigned last night are acceleration problems. They all involve speeding up or slowing down, which means you're going to use anything that's circled in blue there. Doesn't have to be necessarily the same one as I use. Okay? You're allowed to try anything that's squared off in blue because they're grouping equations. All right. Any issues in any of those questions on page 52? I think I'd heard someone say, was it 3 and 4? 4 and 5? 4 or 5? Yep. 6? The answers are actually in the back of the book or the appendix. I think it's called the appendix. So I don't have the answer off my head here, but yeah, the answers are in there if you want to check that. Okay, 4, 5, 6. Any others? All right. Question number 4 says, determine the acceleration of a bullet starting from rest and leaving the muzzle at, so leaving the end of the gun, at 2.75 times 10 to the negative 3 seconds later with a velocity of 460 meters per second forward. Clearly, the bullet is speeding up. Okay, it's speeding up from rest to 460 meters per second, about 1.5 times the speed of sound in about 3/1000ths of a second. It speeds up pretty quickly. It accelerates pretty quickly. We want to find out what that rate of acceleration is. Okay, we're going to expect to get a really big number here because we've got it accelerating from rest to an incredibly high speed in an incredibly short period of time. What do we have given to us here? Looks like time is 2.75. What else? 460. What's that? What's the 460 meters per second? Good. Final velocity. Forward is positive, right? We'll define forward as positive, so everything's going to be positive here. Anything else if I read between the lines here? Got to be something else, right? Got to be something here. Good. It starts at rest, so VI would be equal to 0. Listen, if you ever see the word rest in a question, VI or VF will be 0. If it starts at rest, VI is 0. If it comes to rest, VF will be 0. We're looking for A here, the acceleration, right? Which of those group B equations, because we are dealing with acceleration here, which of those group B equations are we going to use to solve for this acceleration? Which one do you want to try first, anyways? You got 5 options here, right? 5 options. One of them is going to work better, but 5 options to try first. Look at your data sheet. Everybody take that data sheet out right now and have a look at the equations. Eric, which one are you going to use? Good. A is equal to delta V, change in velocity, over change in time. Okay, if you didn't spot that, that's okay. Try another one. This is the most efficient one. This is the quickest way to do the problem, but it's not the only way to do the problem. Delta V is VF minus VI, so it's 460 minus 0. Okay. In the end, if you had just made it 460, you would have gotten away with that, right? But if initial velocity wasn't 0, you'd have to make sure you subtract them then. Delta T was 2.75 times 10 to the minus 3 seconds. What do we get? 460 divided by 2.75 times 10 to the minus 3. Derek, do you have that? Yeah, it's going to be a big number. Yeah. Anybody else get that? Yes? We're actually going to round that to 3 digits. If we go back to our data, it's 1, 2, 3, 1, 2, 3. 1.67 times 10 to the 5 meters per second squared. So Derek was a little concerned there. He said, I got a really big number. I said, it's supposed to be a big number. Let's think about that, right? We're accelerating, Derek, from rest to something that's about 1.5 times the speed of sound in this much time. You got to get to a really, really high speed really, really, really quickly. That means you've got to have a really, really high rate of acceleration. Okay, that's a huge acceleration, but it seems reasonable, yeah. You got a decimal? Like, what do you mean? Okay, so give me your answer. $0.167? 27? I don't know what you did. I'll take a look at it in a minute here, okay? Okay, there's nothing that jumps out at me as probably being a mistake there. What if you just punched it in wrong? I'll take a look at it in a minute here individually, okay? All right, we good other than that? Remind me to take a look at it in a second, okay? Number 5, some aircraft are capable of accelerations of magnitude 42.5 meters per second squared. You ever heard of G-force? This pilot experienced 3 Gs or 4 Gs or 5 Gs. If you're on a field trip at the end of November, beginning of December to the amusement park, you're going to experience, those of you who have the guts to ride on the roller coaster, the big roller coaster, are going to experience somewhere in the range of 4 to 5 Gs. Okay? 1 G is your weight. 2 Gs means that you feel twice as heavy. 5 Gs, which you'll experience upwards of 5 Gs on that roller coaster, means you're going to feel 5 times heavier than you really are. Gs are based on acceleration. Some aircraft are capable of producing accelerations of 42.5 meters per second squared. 1 G is about 10 meters per second squared. So this would be over 4 Gs. So as you're in this aircraft going around a turn, you would experience over 4 Gs. You would feel about a little bit more than 4 times heavier than you really are. Okay? You sustain that for any period of time, what's going to happen to you? You're going to pass out. Yeah? Luckily on the roller coaster, we sustain it for a couple of seconds and we don't pass out. Although you may find that everything starts going black. You start kind of going blind. I find that on the second loop actually that my peripheral vision disappears. Everything's completely black. My eyes are wide open. I'm conscious, but I can't see a thing. The blood rushes out of your head and into your feet when you experience those G-forces. And of course, in order to function properly, your brain needs oxygen, which is carried in the brain. So if the blood's not there, then you're eventually going to pass out. Yes, yeah, normally it would be, yeah. I mean, there's lots of reasons a person can pass out, right? But, on an amusement park ride, yeah, that would normally be it, is that there's a lack of oxygen to the brain, which doesn't mean, it's for such a short period of time normally that there's no brain damage or anything like that, right? It's just your brain needs oxygen. If the blood's not flowing as well to the brain, it's not like the brain is completely drained of blood. But if it's not flowing as well as it's supposed to be to the brain for a couple of seconds, then you're not going to have the oxygen going to your brain that you're supposed to have. So you're going to start passing out. Okay? None of you will pass out on the roller coaster. It's not long enough. Okay? But you will feel it. You'll feel it. Okay? You'll experience an acceleration somewhere in this range on the roller coaster. About 4 Gs or a little bit more than 4 Gs. All right. This aircraft is starting from rest. How long will it take the aircraft to travel down a 2.6 kilometer runway? I'm actually going to circle that kilometer in red there because, listen, I'm dealing with acceleration now. Acceleration, I always want to go to my standard units of meters and seconds. So I don't want to be in kilometers, and I just want to draw attention to that so I remember to convert that to meters. as I'm doing the question. All right, what do we got here? 42.5 meters per second squared. What is that? What's 42.5 meters per second going to be there? Jarrett, what's that one? Delta D, is it? Good, it's acceleration A. Good. What else do we have here? 2.6 kilometers, which I can make it 2,600 meters, or I can just tack on a 10 to the 3 on the end of that and make it 2.6 times 10 to the 3 meters. Allie, what's that going to be? Good, the displacement, delta D. Excellent. Anything else we have here if I read between the lines? Jordan? Good. VI is 0. Okay. It accelerates from rest. Remember we said that in the last question, right? If it's from rest, VI will be equal to 0. Is that all I have? Whoops. Meters per second, not meters per second squared. Is that all I have? I think so. What am I looking for there? How long will it take? What am I looking for there, Zane? Right. Okay, this one's going to require me to rearrange an equation. And sometimes that's a little bit tricky, doing algebra, even though you've done it since grade 7. Okay, algebra can be a little bit tricky. Which equation, first of all, do you want to try? Who's got an idea there? Lewis? Okay, good. That's the one that I would have tried as well. D is equal to VIT plus 1 half ET squared. Now, I'm going to cross this off right away. Why did I do that? I can't just make up an equation. I can't just change an equation arbitrarily into what I want. Why was I able to cross that one off? Tony? Good. 0 times whatever the time is, even though we don't know what it is, 0 times that time is 0. So my equation becomes a little bit simpler now. D is equal to 1 half AT squared. I want to solve for T. Listen very carefully. Pay close attention to this. We have to get rid of everything, first of all, that is not attached to the T. Luckily, in this question, there's nothing that's not attached to the T. That would be the first step. If it's added or subtracted, we got to get rid of that first. Then what we do, we have to get rid of what is attached to the T. In other words, what's multiplied or divided. We have a half and we have an A that's multiplied by T squared. Let's get rid of that. Okay, let's get rid of that first. Let's take the half over. This is the same as AT squared divided by 2. Let's take the half over by multiplying by 2. On the right side, it's divided by 2. On the left side, we multiply it by 2. Now let's get rid of the A. How do I get rid of that one? Good. It's multiplied by A on the right side. I divide by A on the left side. And then finally, I've got the square there. How do I get rid of the square? Good, square root it. So it becomes 2 times delta D over A, square root all of that, equals T. Remember the rules. Get rid of what's not attached, which is addition, subtraction. Get rid of what is attached, which is multiplication, division. Then get rid of squares or square roots. Yep. You know what? That's a good question. Some people, I prefer to manipulate it before I put the numbers in. Okay? That's not a rule that's written in stone, though. If it's easier for you to put your numbers in and then rearrange it, occasionally it is. Occasionally I'll do it that way as well, but not most times. Go ahead and do that. I don't care. Whatever is easier for you. I wouldn't say that there's necessarily a better way. This is just the way that I like to do it. I like to do it without the numbers first. But it's not necessarily better. Okay, 2 times delta D over A. We got 2 times 2.6 times 10 to the 3 divided by the acceleration, which was 42.5. and then we're going to square root that. Let's pull out the calculator here and do this as a group here, okay? Follow along with me on this one. We've got 2 times, remember, we're forgetting about the square root here right now. 2 times 2.6 times 10 to the 3 divided by 42.5 equals. Okay, that's what's inside the square root sign. Now we've got to square root that. All you have to do is hit second function, square root, second function, answer. So now we're going to square root what we got for our answer. Works out to be 11.06. And my final answer should be 2 digits. So we're going to say 11 seconds. Right? That's a pretty long runway, right? 2.6 kilometers? A runway's really that long? 2.6 kilometers? Do you really have a runway at an airport that's almost 3 kilometers long? The new runway at the Calgary airport, which is one of the longest in the world, one of them, is, I forget exactly what it is. It's somewhere between 3 and 4 kilometers long. One runway. I mean, imagine though, you've got an airplane that's the big airplanes that will carry 400 people landing in there. It's massive. It's moving at 800, 900 kilometers per hour before it lands. It's going to take a long distance to stop that airplane. You have to have a long runway. Okay, last question now. Psycho's traveling at 14 meters per second, skids to a stop in 5.60 seconds. Determine the skidding distance, assuming uniform acceleration here. Group B, right? What is this 14 meters per second thing? That one should be an easy one, right? What is that? V1? You're right. VI, close enough. Okay, V1, VI. I usually call it VI, but could call it V1 if you wanted. Okay, good. So it's traveling at that speed before it does anything. That's the initial velocity. Skids to a stop in 5.6 seconds. That's going to be a time, right? We want to find the skidding distance or the displacement. Anything else? Anything else, Carrie? 0 for final velocity. Is that what you're going to say? Right? Good. Vf is equal to 0 meters per second. It stops. The last 2 questions, VI was 0. This time Vf is 0. I'm going to try this one, I think. V is equal to Vft minus 1/2 AT squared. Good news, we don't have to rearrange this one. Good news, that disappears because Vf is 0. 0 times time is 0. Oh, good question. Let's finish this off and then let me answer that, okay? Good question. Negative 1/2 of AT squared is, oh, wait a second. Oh, wait a second. Oops. Oops, I mean, this is not the best way to do this question, not at all. You know what? You know what's funny about this? Sometimes I make a mistake on purpose, just to see what I can get out of you guys. This time I didn't actually. Okay, I actually wrote that equation down thinking that's what I'm going to use here. But then I get to here and realize, oh wait, I don't know what A is. It's not going to work for me, right? Did I get a wrong answer? No. What do? Try something else. Try something else, Ryan. I think that's the better one to use. Yeah, good. Times time, right? VI is, what was that, 14? Yeah, 14 plus 0 divided by 2 times 5.60. Yeah, now that's perfect. Perfect that I made that mistake. Okay, even the teacher sometimes makes the mistake of picking the wrong equation. That's okay. Don't be worried about that. As long as you're picking from the right group, first it's going to happen is you're not going to get an answer. What does that work out to be? 14 divided by 2 is 7. 7 times 5.6 is 42 plus 46.2? Is it 46.2? 39? Ah, it wasn't even close. 39.2 meters. Good. Questions? All right. One more example here. Here it is. Going to have to write this one down, unfortunately, because it's not in your book. Give you a chance to write that one down and to read it, and then we'll do this as a class. All right, let's have a look at this one now. It says a 1,600 kilogram car begins at rest at a stop sign, accelerates, then it travels at a constant speed, and then it stops. What I want you to see with this question is that it's really 3 questions in one. When you see the word then, or something that means the same thing as the word then I want you to break up the question. The car accelerates at stage 1. Then it travels at a constant speed. We'll call that stage 2. Then it slows down. We'll call that stage 3. The mass of the car, whether we're talking about stage 1, stage 2, or stage 3, is 1,600 kilograms. What other information do you have for stage 1? Before the first then, something happens, and then something else happens. What's one piece of information that you have in the first stage there, right? What's one piece of information that you have here? Good. So let's say A is 4.0 meters per second squared. Good. Good. What's one other? Okay. No, it's not going to matter. It's not going to matter. I wrote it down as a given because in the end, it's there, right? And there's going to be times later on this year where math does matter. But no, this year it's not, or at this point it's not going to matter. You don't even have an equation with mass in it, right? At this point. I mean, if you didn't write that down, that'd be okay because you know you're not going to use it. What else? What else you got? Pardon? Okay, in stage 1, the time is 5 seconds. Good. Haley, something else? Okay, in stage 1, the initial velocity is 0, right? Not in the rest of the question, but in stage 1 it is. That's all we have, isn't it, for stage 1? What about stage 2? I think I only see one thing that I have there, Jordan. Time is 34 seconds. Yeah, good. I think that's all we have there, stage 2. What about stage 3? Okay, Vf is equal to 0 because it comes to a stop. Amanda, what were you going to say? Time is 8 seconds. Good. I think that's all we have. Okay, we want to find the total displacement. Remember, when we have more than one displacement, we add them together. So let's get the displacement in stage 1. Let's get the displacement in stage 2. Let's get the displacement in stage 3, and then let's add them together. Here we're going to say d is equal to VIT plus 1/2 AT squared. VI is 0, so that disappears. 0 times time is 0, plus 1/2 of 4 times 5 squared. 25 times 4 is 100, divided by 2 is 50 meters. Good. Okay, got my first displacement. What's next? Now let's go to the second stage. Let's find the displacement here. This is a group A problem because it's constant velocity in the second stage. V is equal to delta D over delta T. Got to rearrange it though. Delta D is equal to V times T. T goes up by multiplying. My problem is I don't know what V is, right? Any ideas? Here's the crux of the question right here. Who thinks they can get velocity for stage 2? No. How do you do it? In the first stage? Good. We're going to say in the first stage, A is equal to delta V over delta T. Therefore, delta V, if we rearrange that, the T goes up by multiplying A times T. We don't need the final velocity in the first stage for the first stage. But the final velocity of the first stage becomes the velocity of the second stage. That makes sense, guys? If you're speeding up to a speed of 20 meters per second, and then you go to constant speed, how fast is that constant speed? 20. 20 times 34 gives me, what is that, 680? 680 meters. Now let's get the displacement in the third stage. Boy, this is a hard question, eh? Do we have any more givens? Stage 3 now. The F is 0. T is 8. Okay? Yeah? Where's the 20 rate here? Right here? The 20 rate here is the velocity in stage 2. Now, how do we get the velocity in stage 2? Well, at the end of stage 1, it was moving at 20. If you speed up to 20 and then go to constant speed, how fast are you moving for the entire stage 2? What's 70? Okay. Yeah. Okay. I was going to say I don't see a 70. No, that's okay. I got a print needle. That's all. Is that better now? Okay. Yeah, no, if that's a 70, that wouldn't make any sense at all. No, you're right. Is there anything else I have given to me in stage 3 now? Read between the lines. There's something else I can write in there. I'll give you a hint. I'm going to write it in red. Derek, you look like you're ready to give me an answer there. Good. The I is 20. We didn't know that before. But now we do. At the end of the first stage, it's moving at 20. During the entire second stage, it's moving at 20. At the beginning of the third stage, it's moving at 20. Now let's say D is equal to VI plus VF over 2 times T. We've got 20 plus 0 over 2 times a time of 8 seconds. It's going to give me 80 meters. Now all we have to do is add these up. 50 plus 680 plus 80. $810 meters. That's tricky, hey? That's tricky. But if you take a step back from it for a second, if you see, look, it's really only 3 questions. It's 3 relatively straightforward questions. Question 1, question 2, question 3. Okay? It's a good question. Your homework. You had already assigned page 53, number 1 to 6. Now we're going to assign page 53, number 7 to 14, please. Sorry, 7 to 14. What did I say, page 53? Should be page 52 then, I guess, shouldn't it? 52, 53, somewhere around there. You can find that page. Okay, that's it.